Okay, so welcome back. So we'll continue our discussion that we have been doing on the permitting process, the design process, as-built drawings. Now we'll get into more details about the design process, and then spend a little bit more on the construction process, because that's many of us doesn't have experience, especially if you are a student who is still in the college and other stuff. You may have done an internship, but it's how the things happen at a construction site. So that will be a useful information for you to have. And although this information is being given under this landfill disposal chapter, you can think about, but it's not only for landfill. It's true for any of the waste management facilities, or for that matter any of the environmental facilities. And if we can go even beyond, many of the things that I'm talking about is true for any construction activity. But most, and especially for environmental facilities, it doesn't matter, water treatment plant, wastewater treatment plant, air pollution control system, or landfills. These are all true for that. So coming back to the discussion that we are continuing, so we talked about the permitting process, we talked about the as-built drawing, and then when we do this as-built drawing, I basically do the design, isn't it? First you have to design, then only you will produce the drawing. So once you have your permit in hand, once you get the permit, you have received the permit from the permitting authority, or a notice of intent, or a NOI, which is again the same thing, to issue permit. So if you get a NOI to issue permit saying that you will get the permit in few days or few weeks, the engineers brings the permit level drawing to construction level drawing. So you start going from this permit level drawing to the construction ready. Construction ready drawing has to have all the details. In more detail, so that people can do the construction. In addition, the construction specification are also compiled. You make a construction specification, like what kind of material has to be used, and all those details, the bill of materials, construction, these things needs to be worked out, and they are specified. They are specified, they are compiled. So that goes along with that. One thing what happens is, especially if the design team and the construction team is separate, although they may be from the same company, but many times the design team, for example, when I was working as a consulting engineer in Delhi, in EIL, Engineers India Limited, we had a design team sitting in Delhi for MRPL phase 2, and then we had a construction team at site at MRPL at Mangalore's at site. Many times what will happen is we'll send, especially since it was a phase 2, the construction drawing was not very proper. So in that case, what was happening is we had the issue of we'll do some modification to the design, we'll propose something in our design, even like the basic design process, but there will be issues on site. Then the letter will come to us. That those days there was not much email culture, was not that popular. So we'll get a fax, and then many times the fax will not be clear, things will not come very legible on the fax, and then we'll try to guesstimate what they are saying, maybe call them on the phone and try to understand, and then try to redo the design, send it back to them, but then they again find out there is a problem. To overcome those problems, I don't know what is happening today in the industry, but some of you should shed the light on that, those who are connected with the industry right now. But Indian context, but in global context, what is happening, and that happened even for our MRPL project, and also for some other projects during that time with EIL, that they made a mobile design team. And like people like me who were still bachelors at that time, we were not married, so we were put on those mobile design team, and we were taken, so we went to the sites, and we were trying to solve this design problem at the site itself, so that time is saved. So that's because client wants the work done to be as per schedule. These days there are a lot of penalty if you don't meet the schedule, and so that was done. So what you do once you have the permit ready, permit approved, you get this permit level design drawing and go for more detailed design, and then you do the detailed design drawing for that. So that's the design process where you produce. At the end of the design process, what you produce is those drawings and the specification. So that's the output of a design process. So as a design engineer, ultimately what you produce is the drawing and engineering drawings, and also the specification. So that's why when you say engineering drawing, I teach engineering drawing class as well to my first years here at IIT Kharagpur. Engineering drawing is your language. It's the language that you need you need to understand each other. So that's actually very important aspect of a engineering degree, to understand those drawings. That's very critical, so you can understand what the drawing is trying to convey. So once the design process, then you go to the construction process. So once now the drawings are ready to start construction. Construction job will be competitively bid. So what we do, you bid the construction. So once the design documents are ready, you have a technical, you do a bidding process, and as part of the bidding process, you will have as part of the construction process, the first thing you will do is have a competitively bid of the construction. A bid package is prepared. So what in bid package will have the construction drawings and the construction specifications. So that's you will have those. You will advertise the bid. The potential bidder can pick up or purchase copies of the bid package, so they can do that. And the potential bidders, which will be the construction companies, will then decide whether they want to bid on the job. So they prepare a cost proposal. So how much it will cost to construct that. Depending on the bid package, the cost proposal may have to be very detailed. So in terms of and then the deadline is there in terms of receipt of the construction proposal. So you have a deadline on how and when you receive this construction proposal in terms of in terms of your for the bid evaluation. So you have this construction proposal coming in. So once this is done, the bids will be reviewed by the engineers and the client. So the engineers could be part of the client, like part of the client team. They have their own engineers, or you may mostly these engineers could be those consulting companies who help with the design process. And then the top bidder will be selected. Which top bidder, this may or may not be the lowest bidder, because there are a lot of other things is there as well, because it has to meet they have to meet certain technical specification and their qualification, their experience, whether they have worked on similar types of jobs. So there are a lot of other conditions are there, and then you come up with those bidding, and the client engineer and the contractor then has to negotiate a contract. So you come up with a contract in terms of timeline, in terms of the payment schedule, and all those different things that they have to do. So the client, normally what they do, they retain the engineering firm or perhaps use in-house engineering staff to oversee the construction of the project. So there will be a project management consultant kind of PMC. So they will do this, either the engineering firm which did the design, they can continue be there as to help with oversee the construction of the project. I have seen that happening many times. In contract negotiation, what we'll do, you will have a start date, you will have a construction period, working hours, reporting and billing requirement, and all those things have to be worked out. Meeting frequencies, these things needs to be worked out. The contractor will set a number of days to reach milestone, like substantial completion, final completion. So those things will be there. So there will be days where they have to reach these milestones and other stuff. So that's the part of that. And substantial completion means all major completion of the project has been completed. Final completion means everything is complete. So all the small like electrical work and all, whatever, many times even for a small building, when they are constructed, you see that although the structure of the building is ready, but there are a lot of work going on. Almost it takes several months to get all those, like a AC system and wiring, electrical wiring, plumbing. So there are lots of small work that goes, and those works takes time, because you don't, and it feels like it has been taking long time because you don't see the progress. When the construction is going on, when the structures are being built, you see, oh, level 1, level 2, level 3 floors are being built. So that you see the progress physically, but the facilities of wiring, AC and duct and this and that doesn't really show much progress, because it's happening within the same structure. So it seems sometimes too long. And the billing, the contractor bills the client. So there will be billing to the client throughout the process as the work is completed. Only work that is completed is paid. Some amount is always held back until the project is complete. The contractor will submit invoice throughout the project. The engineer will review these invoices, make recommendation to the client whether they should be paid or not, that should be paid. So those roles you have to do. As working as an engineer in EIL, we had to do this kind of work as well, especially when I was at the construction site. So and then the contractor will be very specific in the billing. Many times it all depends on how you have negotiated the contract. The mobilization, so mobilization, they get some money for that, bringing all supplies and equipment to site, the materials, completion of task, testing, and those things is done. The contractor is obliged to construct the project at the bid price, unless you can always go and ask for more price in case something delay has happened. But if the delays happen from the client side, its request may be looked into, but the delays happen from the contractor side, it may be refused. It normally may be refused, and then the contractor has to build the things as per the code that they have submitted. So for that, many times what they do, they put a contingency. There is a contingency is normally budgeted as part of the project. So if the contractor finds that project cannot be constructed or as designed, or if the engineer makes changes in the field, a change order will have to be there. So you have to initiate a change order. So because of any change in design based on what was submitted earlier as part of the bid package, so the construction company has the right to go for a change order, and then if the change order is approved, the price will also, they will have some additional cost for that. So then the engineer and client will meet with the contractor frequently throughout the project. There is a weekly meeting. Contractor is asked to summarize work completed, present plans for near future, give update on its staffing, material delivery, submit paperwork. It's basically you do all sorts of things that like a construction supervision and the quality assurance, quality control, all those things needs to be done. And as part of the bid package, the contractor has to submit lots of paperwork prior to beginning work on a specific task. For example, before the liner is placed for the landfill, a liner construction plan has to be submitted. So there has to be a liner construction plan, how the liner will be constructed, how this clay will be compacted. When you see, remember I told you that they will add some moisture to increase the to get that optimum moisture content, so that you can have the compaction better. So how the moisture will be added after compaction, how the testing will be done, which lab will be contacted for testing, who will do the test, and then after you put the liner HDPE, the welding has to be tested. After welding and everything is done, like in the next level you go for piping. So for piping you have the pipe material, pipe schedule. So all those different things, you need the details. So the contractor will submit all these details prior to starting the construction over there. And as a construction engineer or as a consulting engineer helping the client, your role will be, or your role could be on the construction side too. So depending on which role you have, either you will be preparing all these details or you will be reviewing all these details to make sure it is done properly as per the design, so that things meet the required function which is supposed to meet. Questions along the way, they may be able to work out in the field with the engineer's field rep, but the official purpose is to submit an RFI. So if the contractor has some questions, they can usually you can have an informal discussion as well, but if there is something substantial which you want to document for later on for the billing purposes and other stuff, it's there is an official process is submit an RFI. So you request for information. For example, sometimes the drawing are not as clear as the engineer might think, so there might be certain confusion on the drawing by the construction team. So they can submit a request for information, and the engineer, resident engineer from the client side will help resolve this question. So that's those things does happen in terms of construction process. So and then testing of material, that's again I hinted that during that liner construction discussion that we had just a few minutes back. Testing of material is a big part of construction of solid waste management system. So testing is we do a lot of testing of the part of the material. The contractor is required to have in the bid package to have soils, pipes, geosynthetic, etc. tested in the field or by an outside lab, and that lab has to be certain certified lab. It cannot be the lab which the contractor construction company we can just pick. It has to be agreed by the client that that lab will be used. So these lab reports need to be submitted. The engineers, the engineers from the client side can also take additional samples and send them off sometimes as well, just as a cross check, and that's always a good QA/QC, quality assurance, quality control practice, to check whether the lab which you are sending samples to, and if you send it to some other lab, whether the results are matching or not. So that's always a very good idea, because most of this construction, what you're doing, it's like a multi-million-dollar project, so you want to make sure the things are done properly. So testing of material, it's a huge component of solid waste construction of the solid waste management system, or any construction. So once the contractor thinks that they are ready, they request for substantial completion inspection. So there will be a substantial completion inspection. That's they will. So the engineers will come in and they will inspect the site. They make up what is known as the punch list. So punch list is which has a list of stuff which is still left to be worked on. So that is, you will write down each and every item. You go through each unit and then write down for different items what are the works is still left. So that's called punch list. And based on how big the punch list is, what is the status of the construction, you may give substantial completion, or you may not be. It may not be granted. So if you are if a project management engineer from that client side, you will go through the stuff, and based on the punch list, if you feel like it's not substantially completed, feel like means it cannot be just your gut feeling, you have to go by the rules and go by the practice, and then you can come up with whether it's a substantial completion or not. Once it's reached, once the substantial completion is reached, the items on the punch list are completed, then the contractor will request for the final completion inspection. So once they have gone through the punch list, they have addressed all those issues. So when the project is finally complete, the contractor is done, with the exceptions of warranty issues. So usually there will be like 6 months, 1 year, 2 year, 3 year, depending on the project. Different project has different and what were there in your bid package, what you have agreed as part of the contract. So that's it's once that your project is complete, but there is a warranty issue there. So if the contractor fails to complete the process within the contract time, they may be assessed. There may be assessed penalties there. There might be penalties. If the contractor is delayed due to weather, they will request that days added to the project, so that because of anything unforeseen event, that maybe they will ask for request that days be added. And then one of the final deliverable of the product, and sometimes the engineer is set as-built construction drawing, which we have been talking about earlier as well in last video. As-built drawings are very, very important, especially if you want to go for the next phase expansion, which will happen at some point of time in future anyway. These are very important, but these are often neglected, because what happens is you are kind of at the end of the project. You are so tired by the time that you feel like, okay, ab sab kuch ho gaya. So that's you get more relaxed, and then it does get delayed. It does get neglected, and that's we should try to avoid that as a good construction practice, because since next phase when you go for expansion, those as-built drawings are very, very important. So there are other engineering services which is used in terms of the solid waste management facilities. You will have groundwater monitoring, which we talked about in the landfill. It's true for other facilities as well. Reporting to regulatory agencies, other permits, technical issues, closure and post closure. We talked about that as well for the landfill. So there are other engineering services which is required in terms of any solid waste management facility, especially for the landfills. So that was kind of giving you a kind of big overview of how a construction process, how a design, like a project, it's more like a project management basics for a more focused on landfill. This discussion, since it's part we're talking about in the landfill, but the concept is the same for whether you go for composting, anaerobic digester, waste to energy. Some of the terminologies will change, but most part it will be the same. So that's having done that. Some of the aspect of the landfill is still left, which we'll try to cover in the rest of this video. One of them was to predicting the leachate generation. We said that we'll predict leachate, because now you're doing this construction. We talked about all this construction has to be done. You have to do one of the construction was the leachate collection system. So that leachate collection system, if you think about the leachate collection that we had, we were talking about like a sawtooth design. So sawtooth design, where you had something like this, and then you had a pipe in the middle. The pipe has the perforations we talked about. There was a geotextile on top, So now how to know what is the pipe diameter, how much pipe we need to use? We need to first predict the leachate generation, how much leachate is actually produced. So based on the leachate generation, we'll know what will be the what will be the diameter of the pipe. So how we do this leachate generation calculation? What you do is essentially a mass balance for water. So we call it a water balance. So say if this is a part of the cross section of the landfill, and then on the side here is our leachate sump. We have leachate sump right here, and but what we are trying to do is we're trying to find out. So in terms of, so we will have a precipitation, that's the P coming in. Then we have some evapotranspiration going out. We have surface runoff which will go through the system. We will have some leachate that is produced, that's expressed as QL. Then we have there might be some leakage. If it's a well good designed, engineered landfill, nicely constructed, this should not be an issue, but theoretically yes, L is possible. L could be 0 in most cases, but it is possible. So P is your precipitation volume, E is the evapotranspiration, F is the surface runoff, QL is the leachate production, A is the average surface area that we have. And so in terms of the calculation, what we can do is input minus output is the change in storage, we know that. So all the inputs that is coming into the landfill and all the outputs which are going out of the landfill, if we subtract that, that gives us what is the change in storage in terms of the landfill. So here P is the input minus evapotranspiration. So in terms of in the bracket, we have the surface runoff is also going off, leachate is going out of the system, leakage is also going out of the system. So if you do that, that's your delta S. Delta S is what is being stored inside the landfill. So waste, we have some initial moisture content. So you add some more moisture will be added to it because of the waste degrades, it produces moisture. There could be rainfall which has going through, and then as the waste moisture content goes up, there is a point that after that it cannot really hold the moisture, and that's it's called theta FC. Theta here is showing the moisture content in a volumetric term. So it's a volumetric moisture content which we talked about earlier as well as part of the characteristics slide, that you can express moisture content as a volumetric moisture content, which is your theta, which is volume of water divided by the total volume. So theta FC is the field capacity. It is the maximum moisture content that the garbage can hold against gravity. So anything more than that, you will start leachate leaking out from that waste stream. So we have to, the field capacity is the theta FC. What is the field capacity? Is the amount of liquid that a given mass of waste can absorb prior to downward percolation of that liquid due to gravitational forces. So that's what I was trying to explain. So it's all the pore spaces are filled up, and then you have the gravity is being applied to that media. So once you see the first drop of water coming out, that media cannot hold it anymore. That's the moisture content at that level for that media is the field capacity. Then evapotranspiration is the change of water from its liquid phase to the vapor phase. Transpiration is the evaporation occurring through plant leaves through a stomal opening. Wilting point is another moisture content, which is the volumetric moisture content, where the plants can no longer draw moisture from the soil. Then there is another thing like it's a whole information that we are talking about, this mass balance model for the water. They can be done through a rather than doing it in an Excel spreadsheet and other stuff, we have a model which is called HELP model, which is a hydrologic evaluation of landfill performance. So if you go online and you can download this HELP model, and I think the previous versions are available for free, developed by Army Corps of Civil Engineers. So they have done this development of this model. So in terms of how you can start from this model, this is how once you install it, these are how the software looks like. It's still a old version of software. It works on with MS-DOS. It's a free version. The newer Windows version, I think it costs some money, and if you want to get that. So you start with this particular file, and then what you get is something like this, which is the hydrologic evaluation of landfill performance. It's developed by US Army of Engineers long back, and then it was actually done for US EPA. So here, as you can see, you have several several data that you need to enter. You need to enter the weather data, you need to enter the soil data, design data, execute the simulation, view the results, print the results, display guidelines, and you may have to come back and redo it. So that's how it is done. So if we look at one example, so this is one location, Jacksonville, which is in Florida. So if you have the number of year data, so if it's 5 years, landfill area is 5 acres. We have different layers of the landfill: loam, waste, sand, geomembrane, clay. So this is all is there. So we can get the weather data, the precipitation data, temperature data, solar radiation, evapotranspiration. So we can get location and number of years of data generation. So in terms of the evaporation zone depth, every country has this kind of map where you can find out what should be the zone depth for certain area of the country and use that. So there is a maximum leaf area index. Why it is important? It is important for the evapotranspiration. So again, what is the leaf area index, which is leaf area divided by the surface area of the land on which the vegetation grows. So it's a 0 for bare ground, 6 for dense forest. So the other things will be kind of in the middle. So you use that as well. Then you have the soil and design data, which you have the landfill area, you have the landfill design in terms of the thickness, texture, field capacity, hydraulic conductivity, drainage length and slope, geomembrane and geotextile, runoff curve numbers, all those values you need to have there. Then layer type, it could be vertical percolation, it could be lateral draining, it could be a barrier soil liner, geomembrane liner. So those are different layers which is available. So based on these conditions, what we are, and we also look at the drainage length. So our pipe is sometimes actually is in the middle over here. So the pipe will be in this particular point, and we have the leachate coming from here, we have the leachate coming from here. So that's your length, catchment length, actually that's the drainage length. This is the drainage length of half, and then the similar drainage length is on the other side. So it's so you have half over here, similar half is over here. So total, this is your drainage length. So based on the drainage length and the amount of leachate coming into this drainage length, we have to decide what should be the pipe diameter. So those are done based on that. So let's see. So you have this drainage length, you have this curve number, soil texture curve number. So you get all this information. The different USDA classification, also porosity, field capacity, wilting point, and all that, saturated hydraulic conductivity. So you get all these values. You insert this in this help model, and then it gives you the amount of leachate generation. And then we have to design it in such a way so that maximum head on the liner daily peak should not be more than a feet. So when we run our help model, one of the criteria is not to have more than a feet head on the liner. So that's the important, and that's how we do the iteration. So what you could do with the help results, you can look at the leachate generation. It helps in designing of the leachate collection system, helps in the geonet and geotextile design, pump design, leachate storage tank design, leachate storage pond design. So all those things are important. Leachate head on the liner system, hydraulic conductivity of the drainage material, slope of liner, length of drainage path, those things are we can work with those numbers to come up with head less than a feet. Then if we can also predict some if the leachate leakage is there. So those are also when you do that, we can kind of look at that number. So with that, let's conclude this particular video. Only aspect among this landfill chapter is left is on we have predicted the leachate collection. The only part, if you remember from the beginning of this landfill class, we talked about that leachate collection system and the gas collection system. Those two are an important part. So we talked about the leachate, how to predict leachate, and next we will talk about how to predict gas. So that's the only thing left in terms of the landfill disposal, and then we will move to construction and demolition waste and electronic waste. So those are the two big topics which are still left to be covered in this particular course. So I hope you are enjoying this course. We are already in week 10. So this is I think the week 10 first video. We just completed that. So we'll have the second video coming up. Again, any question, put it on the discussion forum. You can that's the forum we are looking at every day. And I hope you are enjoying the course. Keep learning, keep asking us good intelligent questions, and we'll be happy to respond, and looking forward to see you again. Thank you.